My name is Kristina Bush, and my project is called A Challenge to Syriac Paleography, using digital tools to contest modern scholarship. Manuscripts are important because they provide information about ancient times. Historians use manuscripts to understand ancient peoples and what they believed was worthy of being recorded. Of particular import is a manuscript's handwriting, because handwriting is always changing, allowing historians to date manuscripts based on what the handwriting looks like. Paleography is the study of handwriting for the purpose of dating manuscripts. It is important to date manuscripts because a manuscript can tell scholars about a particular time period or the development of a piece of literature over time. Paleography dates back to the 17th century and was originally done only using the eyes, but modern technology has facilitated new paleographical research methods. For the past 3 years, I have been working on the 5CallDH funded project led by Mount Holyoke professor Michael Penn and Smith College professor Nicholas Howe called Modern Technology, Ancient Manuscripts, a project which developed a new technology that uses digital handwriting analysis tools to compare the hands of different manuscripts with the result of matching the script styles of undated manuscripts with securely dated manuscripts for the purpose of isolating a likely date for undated manuscripts. Securely dated manuscripts are just what they sound like, manuscripts with a certain secure date. Often these manuscripts tell us the date they were written in a colophon, or a note from the transcriber telling us the date, the monastery, and if we're lucky, the name of the scribe. My project started as a test of this paleography software using Syriac manuscripts. Syriac is a dialect of Aramaic, which is a Semitic language, meaning that it's related to Hebrew, Phoenician, and Arabic. Syriac was the lingua franca of the Middle East from the 2nd century through the 9th or 10th century CE, when it was replaced by Arabic. By analyzing the world's first large dataset of securely dated handwriting in this language, I am the first to be able to better define how this handwriting developed over time, which will help scholars to better date the 20,000 extant Syriac manuscripts. The true genesis of my project was about a year ago. After the initial phase of collecting and editing letter images, which I worked on for about 2 years, I was asked to note the script type of each securely dated manuscript in our database for a group of outside scholars. In a traditional Syriac paleographical scholarship, there are 2 script styles for the period I'm studying, Estrangela and Serto. Estrangela is defined as an angular script which existed from the 5th century onwards. It can be seen on the left here. Serto is its cursive form, which was developed in the 8th century. A chart of Serto letter forms is seen on the right. You can see how the letter forms are more closed and rounded. For the purpose of this project, I call this system of dividing Syriac into these 2 hands the standard model. My interest in the paleography component of this project peaked when I was trying to use this model to classify scripts. I came across so many manuscripts that didn't seem to fit the definition of either Estrangela or Serto, and I was confused. I realized that the standard model was just wrong. Here's an example of a manuscript that defies the standard model. This manuscript uses an Estrangela form of the letter Olaf in a seemingly Serto text. Confusion caused by manuscripts such as this one brought me to Professor Penn's office, where we discussed the shortcomings of the standard model, and I asked if I could do research on it for my thesis. A major problem with the standard model is that it's the only model used by Syriac scholars, and it's not helpful for dating manuscripts. The prevalence of the standard model in Syriac texts is represented by this image of script charts from 3 different well-known Syriac textbooks. The same letter forms are used to represent each script type in all of these examples. They're basically carbon copies of each other. You can take my word that all the texts also say that Serto was developed in the 8th century. A major goal of paleography is to date a manuscript. Because there are only 2 scripts that existed in this time period, it is very difficult to date a manuscript specifically. For example, if I showed you an image of an Estrangela manuscript, the standard model would only be able to say that it was produced sometime after the 5th century. And same goes for Serto. All I could say is it was written at some point during or after the 8th century. You may wonder how no one has ever caught these deviations from the standard model before. One reason for this could be that no one has had access to a data set as large and comprehensive as mine. There are also very few scholars in this field. Only about 100 people study the Syriac language. Remember how I said there are 20,000 extant manuscripts? There are just too many manuscripts for the number of people who study this language without the help of digital databases and data processing tools, things that did not exist until just now and for the purposes of this project. Over the summer of 2016, a tool was developed by Professors Howe and Penn that facilitated my research on the faults of the standard model, called the Penn-Syriac script chart. This chart takes what the computer software identifies as an ideal image of each letter from each securely dated manuscript and places that image in a chart. I can select to view all the letter forms in only one manuscript, as shown here, or one letter form from all of the securely dated manuscripts. This function allowed me to trace the development of particular letter form over time. I can also view all of the letter forms for all of the manuscripts, which allow me to track the development of each letter in relation to the others and identify the most important letters and dates in the development of the Serto script. This chart, in turn, allowed me to disprove the standard model. There are 5 problems with the standard model that I pinpoint in my thesis, but I will only discuss one of them with you today. That's that Estrangela and Serto forms of different letters appear in a single manuscript by a single scribe. According to the standard model, what makes a manuscript Estrangela is that all of its letters are in the Estrangela form. What makes a manuscript Serto is that all of its letters are in the Serto form. If the standard model were correct, when Estrangela and Serto letter forms are plotted on a graph, it should look like this, where every line represents a manuscript, and each column is a letter whose form varies substantially between Estrangela and Serto and has been identified as definitive to the script type. These letters are Olaf, Dala, He, Rish, Tau, and Wow. The top represents Estrangela letter forms and the bottom Serto letter forms. Based on the standard model, Estrangela and Serto letter forms should never be found in the same manuscript, so the line should never cross from top to bottom. However, when Estrangela and Serto letter forms are tracked, in reality, the graph looks like this. Any line crossing through the center of the graph is a manuscript that defies the standard model. As I mentioned, this is just one of 5 problems that I found in the standard model, so I was motivated to create my own new model of the Syriac script. I propose a new paleographical schema for Syriac manuscripts, the Bush model. My new model has more specific script categories that apply to a smaller date range. Therefore, scholars will now be able to date manuscripts more accurately than ever before. You can see on this chart that each script type has a much shorter range than in the standard model. An early Serto manuscript, for example, can be isolated to date between 800 and 1100 CE. That's much better than saying at some point after the 8th century. This chart even shows the height of popularity of each script type over time. While my project is only a case example in a particular linguistic tradition, the larger goal of this project is to serve as a model for other language groups that wish to use this software. This project demonstrates a tangible payoff that can come from digital humanities research projects. I hope that I will build more interinstitutional databases like the one I used for this project in the future as I study library science with a focus on the digital humanities at the University of North Carolina, Chapel Hill. Thank you.